On our previous video, we looked at how to determine the distance from the center of a central body to the geosynchronous orbit, where we are going to be placing our satellite, which is in a rocket as it is moved to this location. We determined that through the geosynchronous orbit, which is the period, which is 24 hours, using the Kepler's third law. Most importantly, we were able to determine the distance from this particular region to this particular focus region, and therefore by analyzing the radius of the Earth, we were able to come up with the distance actually from the surface of Earth to the geosynchronous orbit of focus. In this video, we're going to be looking at the specific EG. And what is EG and how we're going to determine what it is. EG is considered to be called the gravitational potential energy that is experienced by the satellite when it is on Earth's surface. And this gravitational potential energy of our satellite is based off of the specific central body in combination with the mass as well of the satellite. And to determine that, we're going to look at the specific analysis, and from the analysis we'll be able to figure out how this formula can be determined, not really from our generic m multiplied by g multiplied by the height. We're not going to use this at all. We're going to use something that is relative to the universal gravitational law. Through analysis, we know that when you have a graph that is with relationship to that of the radius, we consider the y-axis to be, in this case here, with respect to the energy, and this energy is going to be measured using our EG, which is the gravitational potential energy. And when we look at Earth, we know that yes, Earth indeed has a radius, which is the surface to be expressed as RE, and RE is going to be positioned around here, which is from our 0 mark, which is located right here. And therefore, when we start measuring the potential energy, we actually start from a negative value and we move higher, and which means in here that from our negative value here, we actually increase in potential energy as we get to infinite distance from the center of our central body to the orbit. Therefore, this shows that we need to in some way overcome this particular potential energy graph, which is known as the potential well of Earth. And so the potential well of Earth is unique to other planets, although this actually shows the same pattern. And the next question here that comes to mind is this: what is the value of this particular starting point on Earth's surface? This value of the potential energy at Earth's surface is expressed as this value, which is negative g multiplied by big M of Earth multiplied by the mass of our satellite, all divided by the radius of our Earth, which is in this case where our satellite, as shown right here, is positioned in, which is from here all the way to this particular point as shown as RE. Therefore, once we're able to determine this, we can then move on to how this is going to make an impact in our overall system, which means that in this case, for our satellite to get out of our specific Earth potential well, it must have the same energy value, but in terms of kinetic energy that will be provided by the rocket in order for it to successfully get to the geosynchronous orbit part. We are now going to determine what our gravitational potential energy is through our analysis figured that yes, we are giving a couple of information. We are giving not only, of course, through research, the mass of Earth, which we determined on our previous video to be 5.98 times 10 to the power of 24 kilograms, but also we were given the mass of our satellite, which is determined to be 5.0 times 10 to the power of 2 kilograms. And next here is, we know that yes, the universal gravitational law is expressed as 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared. And next is determining the radius of Earth, which is the position where our satellite is located at, which is on Earth's surface. Therefore, this value is equal to 6.38 times 10 to the power of 6 meters. And this, remember, is when the satellite is at rest, as shown right here. This value where we're going to determine is pretty much equal to the total energy that the satellite has on Earth's surface when at rest. Remember that information, because that is going to come handy on our next video, where we're going to determine the work done by the rocket in order for it to move our satellite from this position to the geosynchronous orbit. So watch out for that. And therefore, this is going to lead us to what is required, and our required information, that, or the required variable, is Eg, and Eg is determined to be the gravitational potential energy, which is equal to negative G multiplied by the mass of Earth, which is the central body, multiplied by the mass of our satellite divided by the radius of our Earth. Therefore, this here, by putting all these variables and their values into this equation, you're going to come up with our gravitational potential energy to be equal to negative 3.13 times 10 to the power of 10 joules. Take note here that this here is the energy that is bounding our specific satellite to Earth's surface. Therefore, in order for our satellite to completely leave the potential energy well, the rocket must provide a value that is way greater than this number in order for we to be able to successfully, in some distance r from our Earth surface, to get to this particular ideal location and bound to that particular location. So this is how this value is actually determined. This value here is the gravitational potential energy of the satellite that is attached, remember that, to the rocket on Earth at rest. So on our next video here, we're going to look at the total energy that the satellite has at this particular point, or any point around or along the geosynchronous orbit. Hope you found this really informative. Hit a comment down below, let me hear your thoughts about this. By that way, I can talk to you all soon. Stay smart as always, and believe in yourselves.